Now let's see that how the components interact in this specific implementation of MCP. Firstly, initialization step happens. In this step, a host application launches and creates multiple clients. Each client connects to a specific server. During this connection, clients and servers negotiate their supported capabilities. Then in step 2, context request or tool invocation happen. The host, likely via its LLM or internal logic, needs a specific context or wants to use a tool. Then in step 3, the host sends a request to the appropriate client. And in step 4, the client, using the MCP's defined message types, forwards this request to its connected server. In step 5, the server processes the request either by retrieving context from its local data sources, executing a tool, or generating a prompt. Then in step 6, the server sends a response back to the client. And then in step 7, the client relays the response back to the host application. And lastly, in step 8, context update or notifications happen. In this step, servers can also send notifications to clients and thus to the host about changes in the context that they are subscribed to. For example, a file was modified or a calendar event changed. What are the underlying protocol layers? The specific MCP implementation that we explained in this course uses JSON RPC. JSON RPC is the foundation messaging format in MCP. This defines how requests, responses, errors, and notifications are structured. JSON RPC is a lightweight, stateless protocol for remote procedure calls using JSON to encode requests and responses between a client and a server. Then we have capability-based notification system. Clients and servers explicitly declare their supported features during initialization, ensuring both parties understand what interactions are possible. The last one is transport layer flexibility. This one is very important if you are a developer and you want to develop MCP servers. MCP supports various transport mechanisms, including two main ones. One of them is STDIO transport for local process communication, for example, server running as a subprocess, or streamable HTTP transport for remote services, supporting HTTP post for client-to-server message and optional server-sent event for streaming server-to-client notifications. In the next lecture, I will show you that how we can use an existing MCP server from GitHub, for example, and load it into Claude Desktop and use it.